Hello friends, you can log on to primeaptacademy.com to access complete free video courses. So this is the 29th question of the number theory chapter. So question says n is an integer and cube root of number p. Okay, 2 times n equals a perfect square. Alright, then which of the following must be true? So n is an integer and a cube root of p. So cube root of p is n. So from here we can say p is equal to n cube. Okay. Also it says 2 times n is a perfect square. So if 2 times n becomes a perfect square, that means n is a positive number over there. Okay, because 2 times n is becoming a perfect square. Also there is a case in which p and n both can be 0. Okay, here can be a case where p is 0 and n is 0. That is also a case that is possible from here. Okay, but what is true that n can't be negative because 2 times n is a perfect square. So 2n is a perfect square. So 2n is a perfect square. That means n contains odd numbers of 2's in its prime factorization. Why odd number of 2's? Because I am multiplying it by 2 to get a perfect square. So n can have, let's say, 2 raised to 3 2's, or n can have 2 raised to 1 2's, or n can have 2 raised to 7 2's. Okay, only then if I multiply this by 2, 2 raised to 3 into 2 is 2 raised to 4, 2 raised to 1 into 2 is 2 raised to 2, 2 raised to 7 into 2 is 2 raised to 8. When the power becomes even, then only you can get a perfect square. That means 2 raised to power 4, 2 raised to power 2, 2 raised to power 8. This all things only you can get after multiplying by 2 if you are getting, only when you have highest power of 2 as odd in n. Okay, so n can have either 3 2's or 1 2 or 7 2, something like that. N can't have even number of 2's for sure. Okay, also n can be 0 and p can be 0, we have already established it. So n will be of the form 2 raised to power odd multiplied by some, let's say, other number k. Okay, and this k is also a perfect square because n is equal to n. If you do 2 times n, you get a perfect square. So this is k number, some k number raised to power even. This is of the form of n. So n is 2 raised to odd into k raised to even. So, and what is p? P is n cube. P is equal to n cube. So n is what? 2 raised to power odd into k raised to power even raised to power 3. So that will become 2 raised to power 3 into some odd number multiplied by k raised to power 3 into some even number. This is what I can get for p. And we know 3 into odd is odd. This is 2 raised to power odd. And 3 into even is even. So that is k raised to power even again. So p is also of the same form, 2 raised to odd into k raised to even. Okay. But also that is possible that p is 0 and n is 0. Now it says the highest power of 2 that can divide p is odd. Now over here, if I look at it from here in this case, the highest power of 2 that can divide p is this 2 raised to power odd. Okay. So highest power of 2 that can divide p will be odd from here. But when p is 0, any power of 2 can divide p. When you say highest power that can divide is, that means you get a remainder of 0. If I have 0 upon 2, the remainder is 0. If I have 0 upon 2 square, still the remainder is 0. So over here, if p is 0, highest power of 2 can be anything that can divide p. Alright. So this case, is it always true? Because it's saying must be true. Okay. So over here, is this must be true? No. There is no possibility that this must be true. Okay. So highest power of 2 that can divide p is either odd from this case, but here it can be anything when p is 0. Now over here it says the highest power of any integer apart from 2. which is this k. K is apart from 2. That can divide p is even. Now over here we see that k can be the highest power of 2 apart from anything apart from 2 is even coming out from here, which is true. But again we have to look at the case when p is 0. If p is 0, any power can divide apart from 2. 0 upon 3, 0 upon 3 square, 0 upon 3 cube. So highest power can be anything. So is this always true again? No, this is also always not true. So which of the following must be true? None of them. So neither 1 nor 2 is always true, must be true. Had there been a situation wherein this condition is ruled out, had the question stated that n and p are greater than 0, because over here they are equal to 0, but had the situation said that they are greater than 0, then both of them must have been true, because then highest power of 2 that divides p is odd, and highest power of any integer apart from 2 which is dividing p has to be even. Okay, so in that case both of them must be true, but we have this condition where p is 0 and n is 0, so both of them can is not necessarily to be true always. All right, so neither of them are true here. Okay, so that's how we solve this question.